Hello class, in this video we're going to be reviewing over compound interest. The learning intentions of this video is we're going to understand how compound interest works. We're going to be able to calculate compound interest from first principle and going to be calculating compound interest using the actual formula. What is compound interest? Well, compound interest involves the reinvestment of the interest that you've earned from previous years, and that interest that you earned from previous years pretty much earns interest on top of that. So to kind of demonstrate what that means, I've got a diagram on the right hand side over here. So in this, on the diagram, you've got a principal, so a starting amount of $1,000, and the interest rate that the bank has given you is 5%. So 5% of $1,000 is $50, and that's kind of supported over here. So in the first year, you're going to be earning $50. Now, when you're earning compound interest, the amount of interest that you earn or you're charged with always increases for every single year that goes by. So therefore, you're not going to be expected to earn $50 in the second year. Instead, you're going to be earning a bit more than that. In this case over here, you're going to be earning $52.50. The reason why this is a bit more higher than the previous years is because this interest over here that you've earned in the first year, which is $50, also earns interest on top of that. That's why you earn a little bit extra. Previously, in simple interest, the amount of interest that you always earn is always going to be a constant amount. The reason why it was a constant amount because it was only dependent on your principal value, which is $1,000. So in this case, again, if you're going to look at year number 3, notice that the amount of interest you're earning within this year alone is going to be a bit more higher than this previous years. And this is always going to be the case for as the number of years just increase and goes by. So therefore, we say that the interest that you earn or you're charged with through compound interest will always increase because the interest that you've earned will be reinvested, which will therefore earn interest on top of that. What I have over here is a graph that shows you the account balance when you have compound interest, when the compounding frequency is different through compound interest. So what I have over here through the purple line is if you've earned compound interest every single day or continuously, represented by the red line, that's when you're earning compound interest monthly, etc, etc, etc. What I really want to kind of show you in this particular diagram is that when the compound frequency increases, meaning if you're going to be earning compound interest more times within the year, you're going to expect to have a larger amount of money as opposed to earning interest, let's say once a year, which is in this case compounded yearly. We're now going to be looking at examples of how we could actually apply the compound interest formula to calculate the final balance, but also the total interest earned through compound interest. So the formula that I have over here calculates the final balance, which is represented by the letter A. The final balance includes both your interest that you've earned plus the principal on top. So that final balance is equal to your principal, bracket 1 plus, we're adding because the amount of interest always increases every single year. R in this case over here is your interest rate, but it needs to be converted into a decimal. That's why I have represented by a capital R, not a lowercase r. So I should have this as a capital R over here, divided by n. N in this case represents how many times you're earning compound interest. So the compounding frequency. So if it's annually, that means you only earn interest once within a year. If it's biannually, meaning every 6 months, you're going to be earning interest 2 times a year. So n equals 2, etc, etc. Before I move on to that, if you wanted to calculate what is the interest that you've earned, not the final balance, what you need to do is you first find out what your balance is, find out what A is, and then subtract it by the principal. So in the very first example over here, $20,000 is invested at 4.75% per annum compound interest for 3 years. Now, for the first question says calculate the final amount of the investment. Now, when a question doesn't actually tell you whether it is compounded annually, monthly, weekly, biannually, always assume it is annually in this case. So in this case over here, n equals to 1. Remember, when we're using the compound interest formula, we need to convert our interest rate into a decimal. So if you divide that by 100, that's going to be 0.0475. So that's our interest rate. Substitute all the values into our simple interest formula. So if you do this, A is therefore going to equal to 20,000 bracket 1 plus 0.0475 divided by 1 to the power of 1 times 3, which is for 3 years. If you do this, you should get an answer of $22,987.52. To answer for part B, we want to find out what is the total interest earned. This value that you've just calculated here was your final account balance, which includes what you had initially, which is a 20 grand plus the interest. So therefore, to find out the total interest earned, it's simply going to be your final balance subtract by your initial balance. So $22,987.52 subtract by 20 grand. That is therefore $2,987.52. All right, for question 1 over here, notice that in this case, the compounding frequency in this case is going to be annually. So n is going to be equal 1 for all of these questions over here. I want you to please pause the video right now so you can answer these questions and then compare them with mine. So to answer the first question here, simply substitute all the values into the formula. The final balance in this case is going to be $25,088. Part B, if you do the same thing, 14,641. Part C is this, and part D is this. Hopefully your answer is correct and match mine. For question 2 over here, the only difference between question 2 and question 1 is that the compounding frequency changes. It could either be yearly, monthly, or quarterly. So make sure you're changing the value of n appropriately to corresponding to the question. So please pause the video right now as well and answer the questions. So if I was answering part A, you need to convert this into a decimal. So that's going to be 0.15. This is in this case compounded annually. So n is equal to 1. So substitute this into your formula. You should get an answer of $80,911.15. Convert this into a decimal. So that's going to be 0.10. This is compounded quarterly. So quarters, it's 4 parts. So therefore n is equal to 4. Substitute this into the formula. Therefore, this should be your answer. Part C, convert this into a decimal. That's 0.12. This is compounded monthly. So therefore, at the end of every month. So therefore, n is equal to 12 since it earns 12 times within a year. Substitute this into the formula. You should get an answer of $25,394.69. Again, convert the 18% to a decimal, and therefore this should be your answer. Question 3, $15,000 is invested at 5% per annum for 3 years with interest calculated at the end of each year and added to the principal amount. So that's just pretty much saying this is a question related to compound interest. Calculate the total amount of interest compounded during this time. So if we want to find out how much interest we've earned, firstly, find out how much is going to be in your final balance by using the formula. So in this case over here, I've converted 5% into a decimal, which is 0.05. In this case over here, it doesn't state whether it is compounded annually, monthly, or quarterly. So always assume it is going to be annually. That's why I have 1 over here. So if you substitute it into the formula, you should get an answer of $17,364.38. The question wants us to find out the total amount of interest, not the final balance. So therefore, to find out the interest you've earned, it's going to be your final balance, which you've just calculated, subtract by the initial balance, which is $15,000. So if you do this, you should get an answer of $2,364.38. Question 4, Colin invests $5,000 for 5 years at 5.25% per annum. How much would he collect at the end of the 5-year period if the money invested is compounded monthly rather than compounding annually? So we already know from the other slide I've shown you previously at the beginning that the more times you earn compound interest, the greater your balance is going to be. So we already know the monthly is going to have more. So in this case of it, because it's compound annually, n is equal to 1, whereas for compounded monthly, n is equal to 12. We'll substitute all the values in, but first we'll convert this into a decimal. That's going to be 0.0525. So to do that, just divide 5.25 divided by 100, substitute all the values into the formula. So if you do this, you should get $6,457.74. Do the exact same thing for compounded monthly. So I've used 12 over here because it's compounded monthly, and you should get $6,497.16. Note that this value of here is larger than this value here, and that should be the case since you have earning compound interest more times within the year. To find out how much more he made, just go the bigger number subtract by the smaller number. Therefore, the extra money he's made through compounding monthly is $39.42. the last part of today's lesson is we're going to be calculating the balance from first principle. So that just means using the first principle amount, the starting amount, using a table format, find out what the total balance is going to be. So through question 1, please pause the video and answer this question before you compare your answer with mine. So a man invests $25,000, so that's going to be your starting the starting balance of the year. So that's going to be $25,000 over here. The interest rate that the bank has given you is 5%. So firstly, find out what is 5% of 25,000. So it will be 25,000 times 5 times by 1, in this case 1, because I'm trying to find out how much interest I'm earning within that year alone, divided by 100. Therefore, the amount of interest is 1,250. And to get the end of year balance, all I'm doing is adding your initial amount with the extra money you've earned through interest. Therefore, it will be 26,250. That will be your starting balance for the second year. Now, remember, compound interest is different as opposed to simple interest. If it was simple interest, all of these values in this particular column would be the same. However, we know that the compound interest, for compound interest, the amount of interest you earn for every single year will always increase. So therefore, the reason why it increases is because this is now your new principal. So instead of using 25,000, it will be 26,250 times by your interest rate. Therefore, you're going to get an answer of 1,312.50. Add that with your initial amount. Therefore, your end of year balance is going to be $27,562.50. That will again be your starting balance for the third year. You multiply that by 5%, and therefore this is how you should complete your table. We're going to go through another example of here for you to complete the table on your own. So 50,000 is going to be your starting year balance. Find out what 4% of 50,000 is going to be. That's going to be $2,000. To find the end year balance of the first year, just add these two values together. This is going to be the starting balance of the second year. Now, what we need to do again is find out what is 4% of 52,000. That will be $2,080. Therefore, your answer is going to be $54,080. Do the exact same thing, so it's going to be quite repetitive. And if you do that, you should obtain an answer that is similar to mine. Now, again, to show whether this is correct or not, we can kind of say this is true, since that we know that for compound interest, the amount of interest you've earned for each year always increases. So it starts from 2,000 and then increases to 2,080, 2,163.20. This should be the case for compound interest. Now, I've got some extra additional questions that I'd like you to work on. I don't have any solutions for these questions, but if you are following the worked examples and got them correct, then you shouldn't have any problems answering these particular questions over here. In addition, I want you to make sure that you've answered every single question from exercise 1K if you haven't done so previously. However, I am pretty confident that you've done most of these in class already. In addition to that, there was also this worksheet that I've asked you to complete last time. I think most of you have completed that, but if you haven't, please make sure you've answered these questions over here. This is the end of the video. Thank you for watching the video. Please leave a thumbs up if you found this video to be helpful. See you next time.